So the example I did on the slides is for how you can implement the points, which we talked about before. If you want to do a point, we simply did x and y. That's the two attributes. So that's actually one way to actually implement the points. Here is the other way, which you might be aware of. So let me just show that to you. So this is diagram over here. So over there, so the way we did it before, let's say if you want to represent a point over here, so you can simply store the value of x and store the value of y. That's how we did it previously. But there's another way. That's called a polar system. What you store is not an x and y. What you store are two values as well. You're going to store what's the distance between the origin and the point itself. And also what's the angle over here. And once you have done that, you can actually calculate the value of x and y, right? If you only calculate the value for x, it's going to be r times cosine phi, this angle here. And then you want to calculate the value for y, it's going to be r times the sine of phi, right? Just different ways of calculating your points. So now the point is, there are two ways to implement the points. Okay? One is you only store x and y. The other way is you store r and angle. And then, whenever I want to know what's the value for x and y, you will have two different kinds of calculations. Okay? So two possible implementations. And this is what the interface can be used for in general. Okay. Okay, so the first system there is called the Cartesian system, where you just store the absolute values of x and y. That was easy. Hello. And the second system there is actually called the polar system. I'm not sure if you learned that in high school. Maybe you did. Polar system. No.
Yeah.
You did. Okay.
Yes.
Okay. Yeah. But it's kind of an easy calculation. So basically, in the polar system there, we store two things. We store the distance from the origin, and we store the angle. And one thing to note, the angle is not in degrees; it's in radian. Okay, that's some term. That's math related. You can refer back to your high school textbook or something. I would do that in Java because we've got a math class which can do basically everything you can see in a math textbook. Okay, we got two systems, but now the important thing is if you want to make use of the points, there are only two things you care. One thing is how can I get a value of x, and how can I get a value of y? Those are the only two things I care. But how you actually calculate x and y, I don't care. Okay? So now the big picture is we are going to introduce a new concept in Java, which is very similar to abstract class. Okay? It's going to be called interface, which you will use in your assignment 3. So now let me just say that here. So we're going to have a class called points. And then we're going to have two subclasses. Let me just see. For the two subclasses, let me just see the name. So one is called Cartesian. Okay. Yeah, so we're going to have two subclasses. One is called Cartesian points. And then the other one is called polar points. Each one of them is a particular implementation for your points. Okay? One thing to note, in here, point is called an interface. I'll say I here. Okay? The interface is just a special case for abstract class. Remember in the abstract class we said at least one method should be unimplemented. But now in the case of interface, every method is unimplemented. Every method. Okay, no exception. So now, in the point class, we only care about the methods, two methods. One is called get the x value. The other one is called get y. Both of these are simply unimplemented in the interface. So that means whenever we say the Cartesian point is a subclass of points, we're going to implement these two methods. And when we say polar points is a subclass of points, we're also going to implement these two methods. But the way we implement these two methods are different. In the case of Cartesian points, we're simply going to have, let's say, two attributes, double x and double y. Okay, that's a Cartesian system. In the case of polar points, because we store, rather than x and y, we're going to store the distance and the angle. Right? So here we're going to have, let's say, double r and also double, I'll say phi. Okay? So you can see we store different attributes in the two classes. So now, when we want to increment get x and get y, for this case here, it's really easy. You just return x and return y. Agree? Okay. But now, in this case here, it's slightly different. If you want to calculate the x value here, you have to say r times cosine phi. That's what you got to do. And here, if you want to calculate the y, the return value for get y, you have to say r times sine phi. Okay, that's what you got to do. That's kind of the big picture, and then we'll do that job. You can see the big picture here, okay? Which has got two different ways to increment the same interface. So now let's draw some connection to your assignment 3. For your assignment 3, I gave you an interface for birthday, right? Over there, you have methods like how to add an entry, how to remove an entry, how to get the birthday for a particular person, how to remind, etc. And then we said there are two different ways to increment a birthday book. Either you can use one array, or you can use two arrays, right? It's pretty much like you can represent the points using two systems over here. Okay, that's kind of similar. And then in your assignment 3, you have to somehow to say, for the case where I'm using one array to increment all the methods from the interface of birthday book, I have to use only those attributes to increment that. But in the case of two arrays, I have to use the two arrays to increment those methods. Okay. Maybe I'll get to that at the end. Okay. You might be still confused. Okay. Why don't we do this example quickly? It's rather short. Let's do the example first, and then I'll give you a little bit hints for assignment 3. Okay. Okay, that's kind of the idea. And now, so one thing to note. So once you declare, once we get this architecture here, so we're going to make points the static type of some variable. And then since this is static type, so the dynamic type can be the descending classes of that. Okay, it can either be a Cartesian point or it can be polar points, which I will see. We'll show you. Okay, let's go to Eclipse and then let's start a project for today. Okay, 114. Okay. Should do all the classes here. Okay, let's create a new project for today. New Java projects CSE114 Spring 16 Week 14 Lab 2. Okay, let's do that. And now let's create, first of all, let's create a class. Actually, not class, let's create an interface. New, and then interface. You can see that there, right? So for interface, let's call that just point. Okay. So now in the interface, let's say all an interface contains methods only. All methods are abstract, i.e. with no implementation. Okay, so the implementation will be done in the subclasses, not here. So there are only two classes we care. So there are only two methods we care for the points. So one is we're going to say, what's the x value for your points? The other one is, what's the y value for your points? So these are the only two things we care. Okay? But how you get the x, how you get the y, either through the Cartesian system or through the polar system, we don't care. Okay? As long as you give the x and y. Okay? So now, let's see how we can do things. So now, let's go to create another class. Let's do the simple one first. Let's say we have a class called Cartesian points. Okay, Cartesian point. Over here, it's a normal class. So now you can see there's a field here called interface at. Here you can say points. Okay, so that's there. Okay, say OK, and now finish. First of all, you can see that, so we say class Cartesian points increments rather than extends. So this is like a special keyword you gotta learn again. So when you extend from normal class to abstract class, you would say extends. But now for interface, we say increments rather than extends. So that's a distinction. Okay. Increment simply means because all the methods in points interface are abstract, they don't have any implementation. So that's why we have to implement each one of them. And by default, Java just put some default code here for you, as we saw last time. Right? Okay, so now let's see how we can do this. Okay, so now we can say in the Cartesian system, we store the x and y coordinate values. Okay, let's say here we have double x, so this is one of the attributes, and we got another attribute, double y. So we got two attributes here. Okay, so now how do we get x? It's easy, just return x. Cannot be easier. Return y. Okay, let's also have a constructor here. So let's say we have Cartesian point. And then here we got double x, double y. Okay, this dot x assigned to x, this dot y is assigned to y. And we are done for this particular class. Okay, let's try already on tester. Okay. Since we got two classes already. Let's go to Project Explorer and let's create a new class. Let's call it point tester. And then with a main method. Okay, first of all, if you say point p, so that means you're declaring a variable of static type points. Okay, and now, according to the rule you learned after the midterm, so the dynamic type of p can be any class that's a descending class of point, including itself. However, because the point here is an interface, so that's exceptions. So when the class is actually either an interface or abstract class, it cannot be used as a dynamic type because it has unimplemented methods for the same reason. Okay, so now if you try this, if you say p is assigned to new point, so this will not compile because point is an interface, so it cannot be used as a dynamic type. Okay. This line does not compile because point is an interface, so it cannot be used as a dynamic type. Okay. Since it wouldn't compile, let's comment it out. On the other hand, we can say P is assigned to new Cartesian points. Okay, and let's see what points I want to have. Let's say we got 3, 4. Okay, so this will compile. Why? So if I ask you what's why trough will compile, how would you say? Yeah, because you somehow when you say Cartesian points increments, it's like inherits really, just even keywords like increments. Yeah. So how would you say in this case? Because of points, yeah, and the point is a static type of P. Yeah, don't forget the static type. Okay, this line will compile because this line compiles because Cartesian point is a descending class of the static type of P, which is point. Okay, this line will compile. And now let's try this. If you go to the Cartesian point here, we can now override the toString method.
so that when we want to print out the points, we can actually print it out. Okay. So now we can say override the toString method inherited from objects. I'll make it more readable for you. Okay. So now we have public string to string. So now in this case, if you want to get the printout, you would say, let's say we return. So we're going to return the string. Let's say open parenthesis plus. You will simply say get x. Okay. Plus. Let's say a comma with a space. Get y. And then close parenthesis. Okay, like that. Yeah, of course, if you like, you can say this dot get x. And then this dot get y. That's the toString method. So now we override it. So now later on, when we say system.out.println some point objects, it is going to call this toString method. Yeah, again, that's something we learned from the previous lecture. So now I say that system.out.println. If I simply say p. Oh, let me demonstrate something for you. Okay, let's go back to Cartesian points. For now, can we just comment out this method here, as if it was not there? Just comment it out. Okay. It will still compile, but it will just inherit the toString method from the object class, which will only print out the address of the objects. Right? So now, can we just go back to the tester here? Now, if I try to run the program, this is what you will have. So that's simply the address of the object, right? But now, if I go back to a Cartesian point here, and then put this back. So now we have overridden the toString method that's inherited from the object class. Now, if you go back to the tester here, let's see again. To see what's the output for this line here, you have to think about dynamic binding. Okay, let me say this. Implicitly, Java will call p.toString whenever you say p in the system out of print line, implicitly. So now, if you see p.toString, you have to consider which version of the toString method is going to be called. Right? So there are two versions here. The version that's defined in the object class, and the second version is defined in the Cartesian points class, the one we overridden. Okay? So now, how do we decide which version is going to be called? Right? Whenever I say which version, that depends on the dynamic type of P, right? In this case, what's the dynamic type of P? Cartesian point, right? So that means we're going to call the toString version. The toString method, the version of toString method that's defined in the Cartesian points class. Okay? Let's say this. Because the dynamic type of P is Cartesian points, it will call the version, the overridden version, in Cartesian point. Again, that's a simple application of dynamic binding. Okay, let's try the output here. You will see that now we got 3.0, 4.0 rather than the address, right? Because we have overridden the toString method in the Cartesian point class. Okay, so now we are done with Cartesian point here. So I would like to introduce another class, which will implement the point in a totally different way. Okay. So remember, we got an interface here. You might be wondering, in the abstract class, when we say a method is actually abstract, we gotta say abstract, right? But now, in the case of interface, you don't have to, because every method is abstract. There's no exception. So that's why you don't need the abstract.
What's the difference though?
Huh?
What's the difference?
I would say just don't put abstract. Abstract is only for abstract
I
classes.
mean the interface and
Abstract classes, okay. In the case of interface, every method is unimplemented. No, every method. But in the case of abstract class, at least one method is unimplemented. So you may have some methods there that are actually implemented that will be inherited to the subclasses.
Is it better just use the abstract class like every time like you want to use
Yeah.
it?
So in the interface, we're just talking about in string case, where you simply don't want to put any implementation in the abstract class, so then create a term for interface.
Abstract class will work the same way though.
Well, of course, you can certainly create an abstract class of points where all the methods are just unimplemented. Right. Okay, so let's say we have another class that will implement the same interface. Okay, new and then class. In this case, we just have a new class over here called polar points. Polar points, and then the interface here we're gonna have again. So we're gonna select points. Say OK, and then finish. Okay, you can see now the polar points also implements the points. So that's why you have this hierarchy here. Both Cartesian points and polar points implementing the same interface. So now let's see how we can implement the two methods there. So the attributes we store are different. Okay. So here we'd say in the polar system, we store the distance between the points and the origin, as well as the angle in radian units. In radian, not degree. Okay. So now let's see how we can do that. So we've got two attributes here. So now for polar points, so double r. So this is the distance. Okay, also we got double phi, that's the angle. Okay, again, if you go back to the slides, you can see that's the r, and that's the r here, and that's the phi, right? So these are the two things we store for the polar system. Okay, so now let's see how we can calculate the x and y values. Okay? Because as far as the users of the point is concerned, they only want to call the get x and get y methods. They don't care what attributes you store in the class. Okay? So now, how should we return the x value and how should we return the y value? According to the diagram in your slides, over there, you can see to calculate the x value here, we do r times cosine phi. And for the y value here, we do r times sine phi. So how do we do cosine and sine? You don't have to do that yourself. It's already. Did I do something wrong? Wait, it's in any condition. Maybe. This is something like the any condition. Yeah, it is actually. It's actually behind the condition. Okay. Yeah, maybe you just disturb me for a moment. Okay. So now to do the cosine and sine, you can simply call the corresponding methods in the math class, which I'll show you. Okay? That's something you can certainly just by calling the methods without implementing the methods yourself. Okay. Let's see how we can do that. How do we get x over here? Let's go to. Okay, let's see. It would be as easy as, let's do a constructor first. By the way, it's angle in radian. Okay. which means whenever you want to initialize in a polar point object, you have to pass the radian rather than degree. Polar points. So now you can say double r double phi. Okay, it'll be easy. This dot r assigned to r. This dot phi is assigned to phi. Okay, so now let's see how we can get x and get y. So now remember, according to the diagram, we're going to do return the value of r times cosine phi. So you can go to math class dot, they simply have a function called cosine phi, and that's it. Okay, that's just a method you can call. You don't have to memorize the method. If I want to test you on this, I'll tell you what method you should use, and then you can use it. But at least you should know how to call the method. Okay, now how do we get the y value? It'll be sine as opposed to cosine, right? So now here we can say return r times math.sine phi. And that's it. You can see here, we're trying to implement the two methods, get x and get y, in a completely different way, right? In the Cartesian points there, we define these two methods in terms of x and y, the two attributes. And in the polar points class, we define these two methods in terms of r and phi. Okay, so that's completely two different strategies. Okay, so now let's see how we can test them. If you go to point tester over here, okay, so let's see how we can do it. So again, we also have to, let's say we also redefine the toString method here. Okay, toString. Public string toString. Okay, let's say we do a similar. So let's say return, let's say open parenthesis, and then this dot get x, and plus, comma, and space, plus this dot get y, plus close parenthesis, like that. Okay, let's see, plus. Okay, that's how you do the toString method. Exactly the same as how we redefine the Cartesian points. Okay, let's go back to point tester. So now let's say I do P, which has static type points, is reassigned to a new polar points. Okay, so here I'm going to give somehow the some r and some phi. Okay, so now let me just say this. Okay, so here I can see, this is some value you can try. I want to do like a 60 degree. Okay, what's 60 degree in radian? You can actually convert 60 degrees into radian in math, in the math class. Let me show you. Let's say the distance is 5, and then 60 degree, I will get math dot radian to radians, and then here 60 degree. So this really means, this is the point I'm trying to convert this in. Okay, so imagine that. So this is the point P, and then we say that R is 5, and over here is the 60 degree. Okay, but it's just that if you want to calculate the sine and cosine, you have to do radian. So that's why I convert from 60 degrees into radians. And for the conversion, you can just use the method from math class. Again, you don't have to implement that method yourself. You can just use it. Okay, good. After this, we are trying to do system.out.println p. So now the question you're going to think about here is, we know that when you say, if you compare lines 22 and 27, we know that in both lines, p.toString will be called implicitly. Okay? But now, since the dynamic type of p has been changed, so different versions of the toString method will be called, right? So in line number 22, because the dynamic type of p is Cartesian points, so the version that's defined in Cartesian points will be called, right? In line number 27, because we changed the dynamic type of p into polar points, so a different version of the toString method will be called, right? That's something to know. I'll write it down. Since the dynamic type of p has been changed to polar points, the overridden version of toString in polar points will be called. Okay, that's something you should note. All right, let's see the output. Wow, just some value here. Okay. Because you actually have to convert degrees into radian and then do some calculation cosine and sine, so that's kind of the precision you need to have. Okay. But don't worry about the numbers here. It's more important to see the big picture. So you just got two ways to increment the points, and then you got either polar system or Cartesian system. Okay, good. Any questions? Questions? No? Okay, let's do quickly a point collector. And then we just want to reaffirm the ideas about dynamic binding and polymorphism. Can we do a class called point collector? Okay, so here in the point collector we have an array of points, which means each element in the array has a static type points. And also we have the counter number of points. Okay, and then here we have point collector, and then we say points new points, let's say just 10. Okay, and we actually did the exercise before, right, on Monday, to say in the polygon collector you can have add polygon, add rectangle, and also add triangle, right? So I just wouldn't do that here, but you can do the same. You can have add points, add Cartesian points, and add polar points, okay, with different types for the parameters. I'll leave that to you. Okay. Let's now do the most general version. So you can say void add points. Point over here, p. You can say points is assigned points at the number of points is assigned to p, and then the number of points counter plus plus. Okay, very easy. Just note something here. We declare the static type of parameter p as points. This means that the arguments can be of any of the arguments. Can be any of the descending class of points, i.e. Cartesian and polar. Okay? We'll see that in the tester. You can see we're trying to repeat the concept every time, so just to make sure you really grasp that idea. Okay, let's go back to the tester here, and let's say this. Now I want to have, let's say, point collector. PC, new point collector, like that. So now if I say PC dot add points, and I want to add, oh, actually before I do that, give me a moment. Can we now do things like this? Let me just create another 2 points. Okay. So let's say we have Cartesian points CP. It's assigned to new Cartesian points 3 and 4. The same as before. And we also have polar points PP. Assigned to new polar points. I'll just do the same as before, 5, and then math dot to radius 60 degree, let's say. Okay, so we got CP and PP. So now if I now say PC dot add points CP, and then I say PC dot add points PP, both of them compile. But you should really know why. Okay, we did this exercise a few times already on Monday. Again, because the static type of CP is Cartesian points, and the parameter for add points has the static type points, and Cartesian points is the descending class of points. Right? And similar reason for 56. So now, let's run a loop. Print out the points in the collector. So I'm going to say for integer I equals 0, I less than PC dot number of points I plus plus. Okay, over here I'm going to say PC dot points at position I dot to string. Let me say that. I'm just making it explicit. System.out dot print line. Like that. Let's say this. Which means for each iteration, we're going to call exactly the same line with a different index I. How many iterations are we going to have for this loop? 2? How do you know it's 2? That point 2 times, right? That's why it's 2. Okay. So that means the loop counter value is going to be 0 and 1. Okay. So now, because there will be 2 iterations, so that means we're going to, the first iteration, we're going to say PC.points 0 to string. In the second iteration, we're going to say PC.points 1 to string. Okay. So now, question for you. In the first iteration, let me just write it down on the board. Okay, in the first iteration, let me just not worry about the print line. In the first iteration, we're going to have PC dot points at position 0 dot to string. The second one, PC dot points at position 1 dot to string. Okay, we got 2 iterations, right? So now I would like you to figure out, are they going to call the same version of toString or not? Is it? Would you like to try? We can pass it. You want to pass it? Okay. Different? Okay. Maybe, yeah, okay. I agree it's different. How are they different? Explain. True. But what do you mean by different values? It's a bit vague, actually. What do you mean different values?
Does the element at 0?
We PC the point, isn't it, right? Okay.
What does that mean?
You can look at line number 35 and 36.
Yes.
So it seems like we add a Cartesian points first, and then we add a polar points, right? Okay. somehow, okay.
So, because they are different, like the two elements have different
Dynamic times.
yes. That's why.
Okay. Yeah, okay. It's a bit vague. Okay, yeah. Okay, let's see what's gonna happen. Okay. So basically, let me wipe this out. So we got a similar diagram from Monday actually. So now let's see. So you have PC. So PC is a point collector objects. And then in the point collector we have an array called points. And that array there has up to 10 points that you can store, 0, 1, up to 9 over here. Because of line 35, the first element is going to point to a Cartesian point objects. Okay. So I would say CP is a Cartesian point objects, and with 3 and 5, right? And the second one, and index 1, is going to point to a polar points object, right? Because of line 36, okay? It's going to be a polar points object. And over there we have 5 and also degree 60, right? 5 and 60, something like that. So now you can see that the static type of element 0 is points, and the dynamic type for element 0 is Cartesian points. And the static type for element 1 is still a points. And the dynamic type for element 1 is polar points. Okay. So now, back to my original question. When you say PC.points at index 0 string, which version is it going to call? So now it depends on these. It's very distracting. Okay, so now in this case, if you want to know which version of the toString method is going to be called, you have to see what's the dynamic type. Okay? So now when you see this, PC.points at index 0, what's its dynamic type? I think your point, right? So that means we're going to call the version of toString in this class over here. Okay. Similarly, when we go to the second iteration, where we have PC that points at position 1. In this case, the dynamic type is polar points. It's a different dynamic type. So we're going to call a different version of the toString method, which is defined in this class here. Right? So that will be a complete answer, you should say. I think what you said was kind of there, but it's not exactly. I still have 10 days. But I only got 1 day for this instance. Any questions about this loop here? Okay. Again, whenever I ask you about if a line compiles or not, you only have to look at static types. Always look back to see where the variables are declared to see the static types. And whenever I ask you about which version or what should be the output of a particular line, you should always look at dynamic type. Okay. No exceptions. Always the case. Okay, if you have no questions, really? No questions? Okay. If you have no questions, that's it for today. Today is very short. I really just want to cover the interface so you can actually go ahead and do your assignments. Okay. So I would say for your assignment 3, the most important thing is you have to make sure if you want to change the binding of your birthday book. So somewhere in your, let's say you have the birthday book F plus, somewhere you got a main method there. Okay. Over there, you should really have a, let's say, how you did for assignment 2. The way you did assignment 2, I presume, you declare a variable there called birthday, right? Birthday book or something like that. So now, the type of that should be something that's general enough to be switched between 1 array birthday book and 2 array birthday book, right? So I cannot write out a solution to you, but I would suggest you have a look at this particular slides in the class. Okay? Especially if you look at the last slide for the interface. over here. So when I say you want to have your interface as a static type variable, I think that's a hint for you. Okay? I hope that's explicit enough. That's what you should do. And if you want to check what's the current binding, of course, instance of operator. Yeah, assignment 3 shouldn't take you more than 4 hours to complete, I would say. Since you did, I presume you either use the 1 array or 2 arrays to implement assignment 2. So that means half of it has been done already for assignment 3. So just got to implement the other one. And then to reuse your birthday book app main method from assignment 2, and then to just extend 2 blocks of code to do change binding and current binding. And that's it. Shouldn't take more than 5 hours. Did I say 4? Okay, shouldn't take 4. Shouldn't take more than 4 hours. Okay, if you have no questions, we're done for today. Okay, so I'll see you on Friday for the quiz.